So let's complete this flow proof to prove that this is a parallelogram. So angle DAB is congruent to angle CBF. And we're also told that AB is parallel to DC. So we've got our given and the other given. Pretty short proof. So these two angles are congruent. This angle up here at A and this one at B. Those are congruent, which means that these two sides must be congruent because those angles are corresponding. Corresponding angles are congruent, that means the lines are parallel. So that's all it really took. Now we have the top and the bottom are parallel, the left and the right are parallel. So ABCD is a parallelogram because opposite sides are parallel. That's it. So here we've got 4 points for a quadrilateral. So we'll go 3, 4, that's A, 7, -2, 0, -2, and 1, 4. So if we connect that, we've got this flat side right there. And the flat side at the top. That means this is a trapezoid because the top and the bottom are flat, they're parallel, but it's not a parallelogram. So it is a trapezoid. And the area of a trapezoid is 1/2 the bottom base plus the top base. Base 1 plus base 2 times the height. So base 1, that's the bottom down here, that's CB. That has a length of 7. Base 2, that's the top side, DA, that has a length of 2. And then the height, we just measure straight up from the bottom to the top. That has a height of 6. So you plug that into the formula for area, you get 1/2 7 plus 2 times 6. So that's 1/2 of 9 times 6. $27. So this is a square, which means we have a right angle for the entire corner, and it's a rhombus. Squares are rectangles and rhombuses combined, which means that the diagonals are angle bisectors. So this entire angle is 90, but the diagonal cuts that in half to 45 and 45. So 45 degrees there and 45 degrees there. So we're told this side of it, so you set it equal to 45. Solve it out, add the 9. Divide by 6, you get x equals 9. So if this is a parallelogram, that means opposite angles are congruent, which doesn't really help us in this case because we have an x and a y. But it also means that consecutive angles are supplementary, which means they add to 180. So if this angle is 49, this angle in the top left would have to be whatever you get when you subtract 49 from 180. So this angle is 131, and then like we said to start, opposite angles are congruent, so this angle is also 131. So we get two equations, one for the x, 11x plus 10 equals 131, and 14y minus 9 equals 131. Solve each of those, so subtract the 10, you get 121. Divide by 11, x equals 11. To solve for y, we're going to add the 9, so we got 140 equals 14y. So y equals 10. If gt is 6x minus 4 and EA is 5/3 x plus 9, what would the length of GT need to be to prove that it is a rectangle? So if this is a rectangle, that means diagonals are congruent, which means that GT will equal EA. GT will equal EA. To solve this, we're going to add the 4 over. We get 13 on the right. We're going to subtract 5/3 x. And that will get us, we need a common denominator. So change the 6 to 18/3. We have 18/3 minus 5/3. That's 13/3. Or, if you don't like fractions, which many people don't, we can get rid of fractions right away. Multiply everything by 3. So 3 times 6, that'll be 18x. 3 times 4 is 12. 3 times 5 is 15. Divided by 3 is 5. And then 3 times 9 is 27. And now there's no more fractions. It would work out, get you the same answer no matter which way. So subtract the 5x over, you get 13x. Add the 12 over, you get 39. Divide, you get x equals 3. But it doesn't say what's the value of x, it says what's the length of GT. So here's GT. Plug in the 3. 3 times 6 is 18 minus 4. So GT is 14. Since they were congruent, you could have plugged it into either equation, whichever one you like better. Solved it out. So here we have a rectangle. We're told it's a rectangle. And the area is 42. Area of a rectangle is base times height. So if we kind of turn this into a rectangle, figure out how wide the base is. They're both down at -3, so it doesn't go up or down at all. It's just from -4 over to 3. So that's 4 and 3 more. It's got a length of 7. So if the area is 42, which is base times height, the base is 7, That means the height divides, you get the height of 6. So this needs to be a length of 6. So if we're going up 6 units from -3, we're going up 1, 2, 3, and then 4, 5, 6. We've officially counted from -3 up to +3, so z equals 3. Do the same thing on the left side. If you go -3, you count up 6, you end up at 3. Choose all the statements below that prove or disprove that this is a square with these vertices. So I would plot these to get an idea of where to start. So 3, 4, 7, -2, C is 0, -2, and D is -4, -4. No, -4, +4. So certainly doesn't look like a square. The base is flat with a 0 slope, so the other side DC, if it was going to be a square, would have to be vertical with an undefined slope. So we're talking about consecutive sides when we say that, so it's not a square because the consecutive sides are not perpendicular. That's true. DC is not perpendicular to BC. Also, I bet the diagonals are not congruent either. So let's check the diagonals. This diagonal would have a length of that side's got an 11 and 6. 11 squared plus 6 squared. $157. For the other side, the other diagonal, that's a 3 and 6. 3 squared plus 6 squared. 9 plus 36, that's 45. So no, the diagonals aren't the same either. The diagonals are not congruent.